Hello students, I am V K Singh. Today I will be discussing the continued lecture of our previous discussion, that is current electricity. So today will be the second lecture of current electricity and we will be discussing on the series and parallel combination of the resistors. We have already discussed the temperature effect on the resistance and resistivity, and in semiconductor also, in conductors also, and in certain alloys also. Now today we will try to discuss about, we will understand series and parallel combination of resistors. Combination of resistors, first is series of resistors. In series combination of resistors, if there are certain resistors as connected in this way with an external source like this, battery of V volt, suppose this resistance is R1, this resistance is R2, this resistance is R3. In this situation, what we will observe, that the current that is coming from the battery, it will remain same through all the resistors. Here also I current, here also I current, here also I current. Through resistance R1 the I current is there, through resistance R2 the I current is there, and through resistance R3 the I current is there. Only thing is that here the potential drop will be different. Here if we suppose V1, here if we suppose V2, here if we suppose V3, then this potential has been dropped at 3 resistors. So in this series connection, current remains the same through all the resistors and only potential drop is different across the different resistors. One thing you should understand, that you have already, this is very simple because you have already read in your junior classes also. Now here if we want to replace all the 3 resistances by a single resistance, then that is called equivalent resistance. I am representing it by RS. So RS is the equivalent resistance. That means if I replace all the 3 resistors by a single resistor VRS, then this current will remain same through that resistor I. So this is the single resistor RS, and in this situation we already know that equivalent resistance is given by RS is equals to R1 plus R2 plus R3. This is the 3 resistor case. If there are n number of resistors, we can continue in this way, R1 plus R2 plus R3 plus R4 plus R5, like that only. Only difference is that you have to keep that potential drop across each resistor is different. So this is your series combination of resistors. Now second is that we can say parallel combination of resistors. Parallel combination of resistors. In parallel combination of resistors, current electricity continued. In parallel combination of resistors, you will find that the resistors arrangement is in this way. the combination of resistor is like this, and with external source, this is R1, this is R2, this is R3. I current. What you will observe that the potential difference is V. If we consider this side as 0, lower potential, and this side as V, then here also the V is there. So in parallel combination of resistors, the potential difference across each resistor remains the same. Here also it is V, here also it is V, here also it is V. So potential difference remains the constant. Only thing is that the current through each resistor is different. I1, I2, I3. So I1 is the current through resistance R1, I2 through R2, I3 through R3. So this thing you should understand very carefully, and you should understand that the potential difference remains the same. In this situation, if I represent the equivalent resistance, if I represent the equivalent resistance by Rp, then in this situation 1 by Rp is equals to 1 by R1 plus 1 by R2 plus 1 by R3. This is the way if we want to replace all the three resistors by a single resistance, then that should be Rp. So this is the case of your parallel resistance. Combination of parallel resistance. Series resistance and parallel resistance is very simple. You will understand it in a better way when you will see the application. So we have to see the application of series and parallel resistances, that how we will find the current, how we will find the potential drop, and all these things. Now in case of two resistors, the formula has to be remembered so that you can solve the question easily and confidently. See, in parallel combination, the equivalent resistance of two resistors is given by 1 by R1 plus 1 by R2, that is R1, R2, R1 plus R2. Therefore, Rp is equals to R1, R2 by R1 plus R2, that is product by sum. This thing has to be remembered, that in case of two resistors, the equivalent resistance is given by product by sum. And here you can find the current also. For example, here current is I1 through resistance R1 and current is I2 through resistance R2. Now what is the value of I1? In parallel combination, potential difference remains the same. Here lower potential, if I take it as 0, it will be V. So I1 is equals to V by R1. And V is what? V is your I into R parallel. So what we are getting? I into R1 R2 by R1 plus R2 into R1 by R1 is missing. So R1 will cancel. What you are getting? I into R2 by R1 plus R2. So if total current is known, you can find I1. Similarly, we can find I2. I2 is equals to V by R2. V is I into Rp by R2. This is your I into R1 R2 by R2 R1 plus R2. R2 will cancel. I R1 by R1 plus R2. This thing has to be remembered. In case of two resistance, this matter has to be remembered very carefully, and you should understand. This will simplify the situation and you can solve the questions in case of two resistors in a very comfortable way. For example, I am giving you one example. Example is in this way. Suppose here Here 9 ampere current is going. This is 3 ohm. This is 6 ohm. Now, in this situation, if they are asking to find I1 and I2, you can use this formula and you can easily find the result. What is that? I1 will be, from here you can see, 9 into R2 is how much? 6 by 9. 6 ampere. Directly I1 is equals to 6 ampere and I2 is equals to 9 into 3 ampere. So I1 is equals to 6 ampere and I2 is equals to 3 ampere. See, I1 is the current through a smaller resistance, so it should have a larger value. I2 is the current through larger resistance, so it should have a smaller value. So this thing also you have understood, and by this example it will build up your base. It will make you more confident by understanding this concept. So we have seen the basic problem, and in the basic section only I will give you a simple question that is based on the basic concept only. What is that question? Second, in parallel here try to understand that in this question what is given. In parallel, the equivalent of two resistors, equivalent resistance of two resistors is 4 ohm. So 1 by R1 plus 1 by R2 is equals to 1 by 4. Whereas in series, equivalent resistance is 18 ohm. So R1 plus R2 is 18. Here you can write R1 plus R2 by R1 R2 is equals to 4. Put the value of R1 plus R2, you will be getting R1 R2 4 into 18, that is 72. So R1 R2 is 72 and R1 plus R2 is 18. Now you can easily find R1 and R2. First I am trying to get R1 minus R2. Here you see A minus B whole square, A plus B whole square minus 4AB, R1 R2 18 square, 4 into 18 into 4 I am writing. 18 I am taking as common, so 18 minus 16, that is 18 into 2 36. So R1 minus R2 is equals to 6. Take it as equation number 1, take it as equation number 2, and you can easily solve it. R1 plus R2 is equals to 18. R1 minus R2 is equals to 6. Add 2 R1, 24. So R1 12 ohm. You are getting the answer R1 12 ohm, and R2 is equals to 6 ohm. You can take here plus minus also. You can take here plus minus also. The result will be coming same, only at the place of R2 you will be getting 12 and R1 you will be getting 6. So this is the any combination you can take, and then this way we can solve this problem. So these two basic questions, after discussion of these two basic questions, we will move towards some other questions also, but this clarity of concept should be there in your mind for solving the next problem. So in the process of series and parallel combination, we are trying to move the next problem that will also be very helpful to you if you understand it properly. See the question. Now see this question. This is a network that is given in which all resistors are equal, and across AB you have to find the equivalent resistance. RAB is equals to how much? This symbol means that this wire is not touching here. This symbol means that the wire is not touching here. Now how to solve this question? This is basically the potential method of solving questions. What I mean, here is the wire and here is the wire. If I take this potential as V, then this potential is also at V. That means if it is the point A, here is also the point A, and if it is the point 0, if potential is 0, here also the potential is 0. That means if this is point B, this is also point B. After understanding this, the question becomes simple. This complicated circuit, these two are in series. Similarly, these two are in series. Similarly, these two are in series and these two are in series. So what will be the question? The question can be converted into this way, that here is the point A and here is the point B. This A is at potential V and B is at potential 0. So between A and B, this 2 ohm resistor, 2 ohm resistor. Why? R plus R. Between A and B, this 2 ohm resistor. Between A and B, again 2 ohm resistor, and one more is there, 2 ohm resistor. Now it becomes simple. Now all are in parallel. So this should be your answer. This is our answer. R by 2 should be your answer of this network. of this network, what we are getting? We are getting R by 2 is the answer. So this way also the series parallel concept can be applied, can be understood, and it will be helpful to you. So few basic questions we have seen. Similarly, we will be increasing our level of understanding the question from basic to some higher level questions. Hello students. So this is your question, and you have to find I1 and I2. I is equals to how much? I1 is equals to how much? And I2 is equals to how much? Here, very important to understand that the two batteries are there. Now, one concept I would like to tell you, that if a battery is here and it is connected with this battery, suppose this is 10 volt and this is 2 volt. This is a battery of 10 volt, this is a battery of 2 volt. This is trying to give the current in this direction, this is trying to give the current in this direction, opposite direction is there. As this battery is oppositely connected, so ultimately this will be the winner and it will neutralize its effect. So it will be a battery of this polarity of 8 volt, 10 minus 2, that is 8 volt. It will be of this polarity. If it is 12, then it will be a battery of this way 2 volt. So that has to be understood, and the same concept I will apply here also. But first of all, let us talk about the resistance. This is 1 ohm, this is 2 ohm, this is 3 ohm. So all are, if I replace this circuit by a circuit in this way, that is the battery of 4 volt, this has dominated, so I have given this symbol, and then here is the resistor, here is the resistor, I1, I2, and this is your I, 2 ohm, 3 ohm, 1 ohm. This is 3 and 6 ohm. Now, if you want to if this has simplified, now you see these are in parallel. So, two resistors in parallel. So, what will be the equivalent resistance? I have said product by sum. Product is 6 into 3 is 18, by sum 9. So, 18 by 2, that is your 2 ohm. 18 by 9, that is your 2 ohm. Product 18, so it is 2 ohm, it is 3 ohm, it is 2 ohm, it is 1 ohm. So 1, 2, 1, 3, 3, 6 and 2. So this is a situation that you have a battery of 4 volt, 8 ohm. So what is the current? I is equals to V by R equivalent, that is so 1 by 2 ampere current you are getting the value of I. Now when 1 by 2 ampere is reaching here, the potential difference remains the same. So I1 is what? Potential difference. Potential difference across this remains the same. So what is the potential difference? Potential difference across this, if we consider V, then how can we find the I1? I1 is equals to these two resistance are in series parallel, so here we can take them as 2 ohm and the current is your 1/2 ampere. So V is how much? V is equals to IR 1 volt. Now this 1 volt potential will be across this also, because its potential remains the same. So I1 is what? I1 is V by R1 1/3 ampere, and I2 is what? I2 is V 1/6 ampere. So in this way we have been able in finding the value of I1, I2 and I3, I1 and I2. So this should be clearly understood. This is the way we can apply V is equals to IR in series and parallel combination. The next question I will be giving you of the same profile. So now we have another question of same profile that we have done earlier, and here you have to find the unknown resistance R so that this condition is satisfied. Here the current is 2 ampere, 0.2 ampere, and here the current is 0.2 ampere. What is the value of resistance R so that this condition is satisfied? In this situation, how to proceed this question? First stop the video, first do by yourself, attempt by yourself, and then you see the solution. So here you see 5 and 5 are in series, and this series 10 ohm and 30 ohm are in parallel. So 10 into 30 by 10 plus 30, 40. So what you are getting? Better you say in this way, better you understand in this way that if I want to find the current, so 5, 5, 10 and 30. So these resistance will become 30 into 10, 30 into 10 by 40. So it is your 15 by 2. And here 15 is in again parallel. So this is giving you 15 by 2 into 15 by 2 plus 15 product by sum. So you are getting So you are getting 5 ohm. So all these values are giving you the 5 ohm, and 5 ohm, if 5 ohm is going, is 5 ohm is the resistance, then the potential, now you replace this battery, 6 volt battery and 2 volt battery. So you have a circuit, equivalent circuit in this way. This will be 4 volt that will be effective. So this is the 4 volt that will be effective. Here is your 5 ohm. Here is your 10 ohm, and here is your 0.2 ampere. Here is also your 0.2 ampere. This is R, this is your 5 ohm. So what we are getting? We are getting voltage is your 4 volt. So V is equals to I, R equivalent. R equivalent is how much? 10 plus 5 plus R. So 0.2 into 15 plus R. V is how much? 4. So 4 is equals to by 0.2 15 plus R 0.2 20 is equals to 15 plus R. So what we are getting? R is equals to 20 minus 15, that is 5 ohm. So here the value we have got that if the value of R is 5 ohm, we are in a position to get the same result. Again you try to understand. The circuit is there, you have to find the value of R so that this condition is satisfied, to 0.2 ampere should go. Here you see, this is series, so 10 and 30 are in parallel, so equivalent resistance is 30 into 10 by 30 plus 10, 30 plus 10, so it is your 15 by 2. Now this 15 by 2 and this 15 is again in parallel, so 15 by 2 into 15 by 15 by 2 plus 15, and it is giving you 15 into 15 by 2 into 45 into 2, so 5 ohm. So this whole set can be replaced by a single resistor, that is your 5 ohm. R equivalent. This is series and parallel combination. That application is there. So this is 5 ohm. This value is not known. This value is 10 ohm. Now these two battery are replaced by a single battery opposite. So this will be the winner, and 4 volt is in this way, and you are getting the 0.2 ampere current. Now 0.2 ampere current flows through through the circuit. So what is potential difference? V is equals to IR. So V is equals to R equivalent. R equivalent is how much? 10 plus 5 plus R. So 0.2 into 15 plus R. So we are getting R is equals to 5 ohm. In this way, this question will help you in understanding the concept of series parallel and how we find the resistance, how we find the current. In earlier question we have seen, and it will give you a better understanding. So we have to solve this question, and we have to find I1 is equals to how much, I2 is equals to how much, I3 is equals to how much, and I4 is equals to how much. This is the question. Now in this question you have to understand that series parallel is there and battery is added, 10 volt battery is there. So this 15 and 30 and 15 are in parallel. So what will be the equivalent resistance? 1 by R is equals to 1 by 15 plus 1 by 30 plus 1 by 15. Parallel, these are in parallel, see, these are in parallel. So this is giving you 32 plus 1 plus 2, 1 by 6. So R is equals to 6 ohm. If we want to replace all the 3 resistors, then they can be replaced by a single resistor 6 ohm. So I am writing an equivalent circuit. So the equivalent circuit is like this, and then the current that we are getting I1 should be V by R. So V by R equivalent is how much? V is your 10. series 10, so I1 is equals to 1 ampere. So you are getting I1 is equals to 1 ampere. You are getting I1 is equals to 1 ampere. Now, if we want the potential drop across this 6 ohm resistance, then V6 is equals to 1 ampere into 6, that is 6 volt. So here also 6 volt, here also 6 volt, here also 6 volt, because these three are in parallel, the voltage remains the same. So out of 10 volt, 4 volt is dropped here, so here it is 6 volt. Here also 6 volt potential difference, here also 6 volt potential difference, here also 6 volt potential difference. Now the question becomes simple. I2 is equals to 6 by 15, that is 2 by 5 ampere. I4 is equals to 6 by 30, that is 1 by 5 ampere, and I3 is equals to 6 by 15, that is 2 by 5 ampere. In this way, we have solved this equation, we have solved this circuit and this circuit problem. So slowly we are moving from simple basic level to the higher level problems, and it will build up your concept in such a way that you will be feeling comfortable. If you are able to enjoy solving these problems, that means your learning is effective in nature and it is going to help you. But if it appears boring and troublesome for you, that means clarity of concept, more clarity of concept is required. So the next problem that is with we people is here. 4 ohm resistance, 4 ohm resistance, 1 ohm resistor, 12 ohm resistor, 6 ohm resistor, 1 ohm resistance and 6 volt battery. And here you have to find the voltage drop VAB across this, what is the voltage drop, and VCD across this, what is the voltage drop. Basically, in order to solve this question, first thing is there to understand what is the current. What is the value of this current? In order to get this current, this 4 are in parallel, so 2, 12 and 6 are in parallel, so 4, 12 into 6, 12 into 6 by 12 plus 6, so this is your 4 ohm, and this is 4 into 4 by 4 plus 4, 2 ohm. So this is your 4 ohm, this is your 2 ohm, this is your 1 ohm. So 4, 1, 5, 2, 7, 1, 8. So I is equals to V by R equivalent, that is V is your 16 by 8, that is your 2 ampere. So we are getting 2 ampere current. When we are getting 2 ampere current, then potential drop VAB. VAB is how much? VAB is IR. I is your 2 ampere. R equivalent is how much? R equivalent is your 2 ohm. So I into R equivalent, 2 into 2, that is 4 volt. This is your first answer. Then VCD, they are asking VCD. Current 2 ampere, here it will be going 2 ampere. So 2 ampere across this, what is the result? VCD I into R equivalent. This time I is your 2 ampere, R equivalent is how much? 4, 8 volt. So this is your 4 volt will be the potential drop here and 8 volt will be the potential drop here. So in this way we have solved this question. I hope that this much amount of discussion of solved examples will help you in understanding the concept of this series and parallel and potential drop in a better way. But this has no meaning if you will not do the practice. Your practice is more important than my teaching. My teaching is important, but your practice and your effort is more important, and then it will make my teaching to be the effective in nature. So work hard, do more practice as far as possible, and build up your confidence to avoid the mistakes, silly mistakes in the examination. In the next class, in the next lecture, we will continue our discussion of series and parallel with some advanced problems.